and share screen. Oh. Okay, so for today's class, I will continue the discussion still on the force and moment and couple as well. But for today, uh, I will start with the resultant. Okay, what is resultant? I think this one is still a little bit wrong. We're supposed to wait a minute. Sorry, we're supposed to put it as hmm, okay. We will talk about the resultant, right? But we will concentrate on the uh, resultant of the force, couple, as well as the moment. Okay. Um, Let me put it in the full screen. Okay. The first thing that I want to talk about is how can we uh, move force from one point to another point, which is not in the same line of action. Remember, last week I already told you guys that force, you can move a force anywhere as long as it's in the same line of action. Okay, for example, if I have a force like this, and this is my line of action, okay, I can just replace this force with another force with the same magnitude, okay, but still in the same line of action. So you can just move it anywhere you want without consequence, okay, without any consequence. I believe you already understand about that, right? But the things that I want to discuss today is if I want to move one force, hmm, if I want to move one force, okay, anyway, if I want to move one force from one line of action to another line of action. For example, I want to move a force. So let's take a look at this, right? Okay. I want to move a force A here. Okay, I want to move force A here to this particular point, point C, for example. Okay. Based on our previous discussion, actually we cannot do that freely. Okay, because we can only move force without consequence in the same line of action. But if it's not the same line of action, for example, if I want to move that particular force A to point C, then the line of action, if I move it at point C, it will be like this one. That line of action is different from the previous line of action. Okay, so we cannot move it freely. But if the question is, can we move it or not? Okay, the answer actually yes, we can, but with consequence. What is the consequence? Okay, let's try it. Okay, I want to move the force A from that point, the previous one, to point C. then I created another force there. But if I do it this way, this condition is not in a static balance with the previous one. So it's not in the same condition as the previous one. Okay, because the previous one, we only have one force like this, right? Force A like this. And this is point C. Okay, this is the original one. Now, I want to move the force A to point C. So I add another force at point C, the same value, at the same magnitude as force A. But if it's just doing it this way, it's not in the same condition. So number one, system number one and system number two is not in the same condition. Okay, but if I do it this way, I add another force here, exactly the same magnitude, exactly the same direction, but opposite, sorry, exactly in the same line of action, but opposite direction. Okay, you can see that actually these two forces, this one and this, both forces, actually, if you sum both forces, the value, the resultant of both will be equal to 0. Correct or not?
Because they cancel out, yes, sir.
Yes, correct. Because they cancel out each other. Who said that?
Me, sir.
Ananda. Okay, yeah.
Yes.
So, because they cancel out each other, the resultant of both forces, these two forces, right? Why I make it like this? Okay, this one and this one will be equal to 0. Okay, so actually, the system, first system, the first system and the second system, in the current condition is actually the same. Correct or not, Ananda?
You mean the one with one line and with the one with 3 lines?
Yes, correct. So this one and this one is same. The first one and the second one is actually the same. Both systems are the same. Correct or not?
Oh, yes, because the C1 cancels
Yeah.
out and
Yes.
kita in the A only.
So it's actually the same. Both are actually the same, right? So now we have an idea to move one force to another point. How? Actually, the one that we need right now is just this, right? In order to move force A to point C, what we need is just that, right?
Yes.
Correct or not, Ananda? Okay. Now, let me, I want you to help me, Ananda. Can you see these two forces?
Yes. The A and the opposite of C.
Yeah, this one. Okay, then let's name it. This one I name it as B. This one I name it as C. Okay. Force
Okay.
A, force B, and force C. Force A and force C, the direction, is it parallel or not?
Do you mean opposite or not? Or
No, parallel.
oh no, not parallel.
No, it's parallel. It's parallel. It's actually parallel. Because the line of action just now I created from the beginning is parallel. So these two line of action is actually parallel.
Oh, you mean oh yeah. Oh, yes,
From the beginning I created is parallel. So force A and force C is in the parallel direction, but the direction is opposite. Correct, right?
Yes, correct.
Okay. That kind of forces, that kind of force system, we can call it as what? Remember what I told you last week?
Is it
What we normal couple? Correct. This kind of force system, we call it as couple. A and C is a couple. Okay. So basically, if I ask you, can we move? If you ask me, can we move force A to another point which is not in the same line of action? Okay, we can, but we will create a couple there. So actually, you can do it this way. This is the force system. This is force A. You can. This is number one. Okay? You can move it to location C here, okay, like this. You can move it. If this is force A, you can move it to location C here. You can, but by doing so, you will also create couple. The couple here, okay, the magnitude there is the same as F multiplied by D, where D is the perpendicular distance between the location and the first line of action. You get it, Ananda?
I see.
So it's basically similar to the conventional way.
Yeah, actually similar to conventional way, but I need to tell you guys what the process. How can we move it from one point to another point? Actually, the first thing that we're supposed to do is to create two forces at that location where we want to move it to. Okay, and those two forces has the same exact magnitude as the force that we want to move. Okay, and the direction is parallel with the previous force. Okay, then after that we can find a couple there and replace it with a moment. So at the end, our end results will be like this. Okay, at the end, our end results will be like that. Any question?
But the F must be same. The F value.
Oh yeah, yes, correct. We are not changing the magnitude of F. We are not changing the direction of F. What we change is just the location of F. So the direction is still pointing to the same direction because the line of action of force A at the original location and force A at point C, okay, the line of action is still parallel actually. Okay, these two line of action is parallel to each other. You get it, Rizky? Yeah, Nanda? Yes.
So sir,
Azhar,
the net moment of a body is same throughout, no matter the position, given the same direction and magnitude.
Sorry, I don't get your question.
So the net moment in all the surface of the body is the same, given the same magnitude and line of action and direction. Hello?
You are asking about moment or force?
The moment.
Moment. Okay. Let me answer it. If you are talking about moment, okay, if we have this one is, for example, this one is a particle body. If I have a moment like this, or couple or moment like this, okay, this is moment, okay, the effect of this particular moment to this point, for example, this is point A, to this point, point B, to this point, point C, will be exactly the same. Okay, will be exactly the same. Okay, but that's not the same thing. That's not the same thing for force. Force is different. Why? Because when we are talking about force, we have line of action. If you ask me, what is the actual effect of the force, this particular force, to this particular point? This is point A. Yeah. Hello. This is point A. This is point B. And this is point C. Against point C, against point B, and against point A, it will be different. Against point B, it will be different because point B is in the same line of action as the F. In that case, the effect at point D, it will be just force. But the effect of this particular force at point C, okay, it will be force and moment, because you have to move the force, okay, from the original line of action to point C. The same way as I told you before here. Do you get it, Asep?
Oh, okay, sir.
Yeah,
Okay.
I'm asking you, do you get the point on it?
But it's like a bit vague though. Is it like
Mhm.
when we exert it on the like in the point B or the other points that are on the line of action, or
Hmm?
the magnitude, will the magnitude be like propagated or
Oh yes, it will be different because it depends on the perpendicular distance d. Yeah.
oh I see.
So for example, if I want to move force F to point C, for example, okay, this is the new one, okay. This is the new body. This is D. Previously, this is our line of action. Now I move it to point C. This is the new line of action. Still in the same direction, but parallel to it. Okay. And the perpendicular distance is this one, right? We call this perpendicular distance as D normally. Okay. Then this is C. Then the force, we can move it here. But because we move it to different line of action, okay, there will be effect of that. What is the effect? There will be the moment will be there. Yeah, sorry, the force will be there, but plus there will be a moment, additional moment. And what is the value of the moment? Is the magnitude of the force multiplied by the perpendicular distance here, d. Okay, then I think I will replace this with e. E.
Sure.
Okay. So multiply by d, where d is the perpendicular distance.
Sir,
Mhm.
how do we know the direction of the moment?
How do we? It's very good question. Now try to imagine. Okay, try to imagine ourselves. Okay, if the center of rotation is at point C, okay, I assume that the center of rotation at point C, okay, and F is still original here, and the F is still at the original position. I believe you can imagine the rotation, the rotation, the rotation direction, right? Asep?
Oh, yes, sir.
Oh, that was
Yeah.
Zeke, sir. But
Oh, just
I
now
would
was
also
it?
like
Okay,
to
then.
know.
Okay, see. So can you imagine the rotational direction? See,
Yes, it will be clockwise, right?
clockwise, correct. So that's why I draw here as a clockwise moment in this part.
So it depends on the force direction or what, sir?
Sorry,
It depends on the point or the force direction.
it depends on both. It depends on the force direction and depend on the location where we want to move the force. For example, if I want to move to another location, for example, G, location G there, okay?
Okay, sir.
The center of rotation will be at point G, right? And in that case, the moment later, after we move the force to point G, it will be counterclockwise, right? See?
Wait, sir. How could it be counterclockwise, sir?
No, man. Now I want to move the force to point G, this one. You get it or not?
Yes. Okay. Yes.
This one. So that point will be our center of rotation. Huh?
Yes.
So now this is the new body, the one. Now I move the force to point G. This is the new force. Okay, this is the old one at point C. Okay, I move it from this one to this one.
Yes.
This is point G. Where is my point G at? This one is point G. Okay.
Yes.
Of course, in this case, I will have to add another moment, right? Because I moved the force.
Yes.
This one is the original one.
Oh,
So in this case,
okay.
there will be additional moment of counterclockwise, and
Yes.
the moment will be F multiplied by Okay, this one will be, this is the line of action, and this one will be my D2, like that,
So
perpendicular direction number 2. So this one is like this.
so it depends on where we move the force, right?
Yes, correct. It
Okay.
depends on the direction of the force itself and where we want to move the force.
Okay.
To the left, to the right, like that.
Yes.
Okay?
Yes.
Okay. Anyone else here want to ask question? Because this one is
Sorry,
very
sir.
important. This one is basic. Yeah, Ananda. Yes.
Sir, can you go to the previous slide?
Can we go to the previous slide? Yep. What's wrong, Matthew?
Is the object pivoted at B or it's not?
Sorry. What is your question?
Is the object
Huh?
pivoted at point B?
If the object is
Is the
pivoted.
object
Oh, pivoted in point B.
Yeah.
Not necessarily. This one is just the question here is just I want to move force F from point A to point B. That's all. It's not because the pivot is at point B. No.
So sir, the object will move and will rotate, yeah?
Oh, yes, correct. At the end, yes, it will move and it will rotate as well.
Okay, thank you, sir.
Sir, I still don't understand in this picture too. Because if in my logical thinking, the F is to the clockwise, right? The F as if she's with
Which one? This one.
without analysis. I'm
This one or the next one?
the next slide, sir.
The next slide. Okay, this one. Yes.
This is
Okay. I will explain you one more time. Okay.
Okay.
This one is the original one.
Yes.
This one. Okay. Number one is original one. Number two, if we want to move the force from point, this one is what? Point E to point C. And the third one, the third drawing is where we want to move the force from point E here to point G, like that. Okay. So
Okay.
what is your question again?
I still don't understand why when you move from point
Point.
E to G,
Point E to G.
why
Yes.
the
Right.
rotation is anti-clockwise?
Point
still
E
don't
to
understand.
G. Yeah. In that case, the way to imagine it is the point where we want to move the force to, we put it as a pivot, center of rotation. Then
Okay.
try to imagine the rotation which will be caused by the old force before we move it to that particular point. Whether it will be counterclockwise or clockwise. So if I put G as our center of rotation, so this one is our center of rotation, G is at our center of rotation, G is our center of rotation, then I have this force, right? F at point E, going that way, right? Correct or not?
Yes.
Then where is the rotation then? Clockwise or anti-clockwise?
It's clockwise, sir.
No, it's not clockwise. It's supposed to be
Wait.
anti-clockwise, right? This is the rotation, center of rotation. The force is going like that. It will move like this, right? This one is anti-clockwise.
Oh yes, anti-clockwise.
That's why the moment is anti-clockwise. This one. That's why the moment is anti-clockwise. And the magnitude is F multiplied by D2, where D2 is the perpendicular distance from point E to point G. You get it?
I still don't quite get it, Kak.
So make it like this. Never think that moment is always clockwise. if you think that way is always clockwise, okay? So for example, for example, I have a force like this. This is the center of rotation, okay?
Yes.
So that force will cause what kind of moment to this particular point?
Anti-clockwise.
Anti-clockwise. This is the same way as this one. The same way as this one. The center of rotation is on the left. Then there is a force. Then the movement will be like that. Okay. After you move, I think I know what is your confusion. Then why? After we move it here, the moment is still counterclockwise, right?
Yes.
It's because we're supposed to think it. If we're supposed to think the body as the original body, where the force is at the original position. Where's the location is? Where's the rotation is? Clockwise or anti-clockwise?
Oh, so it's based on the original.
Original. Yes. The rotation is based on the original body, the original location. But after you move the force, yes, there will be a force. Okay, the force you move it, but the moment will still in the same direction as the what we think in the original body.
Oh, like that. Okay, okay.
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 So for
okay.
example, okay, if I push things like this, okay, like at the center of rotation, it will be just moving like this, right?
Yes.
Okay. Then if I push slightly upwards here, okay,
Yes.
this is just the same concept. Right? I move the force parallelly and at the top location like this. What will be happening? It will still move.
The
It
same.
will still move, but it will rotate as well. Right?
Yes.
Okay. It will rotate, and the rotation will be counterclockwise. Right?
Yes.
Because like that. Because it's like that. The same as that one just now. So the effect when you move the force, it will be force, the same force plus moment. And how
I
you
see.
think the moment, the rotation will be, is supposed to base on the original part. Do you get it, Ananda?
I get it. I get it.
Yeah, very good. Anyone else here? Because I want to make it as slow as possible because this is the basic concept. So I want to make sure that you understand. That's all.
Sir,
Hmm?
can you
Yeah.
make another example so I didn't interpret what you say?
In that case, it's better for us to discuss about.
Yes.
Wait.
Okay.
I think, yeah, this sample is supposed to be good enough. How can I delete this? Wait a minute. Please open. System is open. Wait then. I don't know how to use tablet. Okay then. Let's try to do this. Okay. Together. But please ignore the two red lines there. Okay. I'm pretty confused myself how to fix this. This okay. Okay, delete. Yeah. Okay. Then now I can share again. Share screen. Start now. Sorry for the delay, okay? Because I'm not used to this tablet mode. I'm still waiting for the new battery to come. Okay, let's try to do this together. I believe most of you will be able to do this. The first thing that you're supposed to do is try to understand the problem. Okay, the first thing that you're supposed to do is to understand the problem. The cantilever, okay, is subjected to 8 kilonewton force, as what you can see in the picture, the red one, okay. And it's happening at point A. The force is happening at point A. Then the next thing that you're supposed to do is to determine the equivalent force couple system at the centroid of the beam across section at cantilever O. At the centroid of the beam, at the centroid beam cross section at the cantilever O. At the centroid of the beam cross section. So, okay then, we assume, okay, let's assume that the question here is, we are asked to move force F, 8 kilonewton, force F, 8 kilonewton, from point A to point O. Okay, what's the effect that will be happening there? Besides the forces, what will be happening there? Okay, Ananda, just now you're asking me, right?
Yes.
Let's, in order to make sure that you understand, let's try to do this. Okay, how can we do this? Moving from point A to point O.
Maybe make a parallel line to
Parallel line. How to
the
parallel
force.
line? Also, line connect, line which connect from point A to point O, like that. You mean?
Yeah, so there's a perpendicular distance like that. So we
Okay,
can
so this is the first line. Okay, so that's the first line. That's a assume that their line is straight. Okay. Okay, so this is the line. Then this is the line of action, first line of action. And this is the second line of action at point O. Okay. Now, what else are we supposed to do?
Can we separate the components?
Find the distance between O and A.
Find the distance between O and A. Find the distance or perpendicular distance?
Perpendicular distance.
Perpendicular distance. Okay. O and A, actually, we can find the distance already, right? We have 3 meters and 0.65 meters divided by 2, right? We have this kind of triangle. Okay, we have this triangle. So the horizontal one will be, it is 3 meters. The vertical one is 0.65 divided by 2. Correct, right?
Yes.
Okay, then we can find the distance from O to A, right? Okay, then what else that we're supposed to do?
Pythagoras maybe, and then search for the perpendicular distance after that.
How? That's the question, how? The perpendicular distance is supposed to be like this, right? This is the perpendicular distance that you're supposed to find. How can we find it?
You use the angle given.
This one is 30 degrees, remember, right? This one is 30 degrees as well, huh?
Yes.
And in the middle is 90.
In the middle is 90, yes, correct. This one is 90 degrees. What else that we have?
60 degrees, I think.
Which one, 60 degrees?
On the left side of the 30.
Inside.
Inside
above
here.
the right angle.
Ah,
Below,
but this one, okay? Remember this one.
Yes, the all
Yeah,
yes.
60 degrees. So in that case, what we can do is we can try to find this angle, right? The small one. We call it as alpha, right? Because we have 0.65 divided by 2 and 3 meters there. So we can find tangent alpha is equal to 0.65 divided by 3. Correct or not?
Yes, correct, Pak.
Sir.
Absolutely.
And this angle is supposed to be 60 degrees minus alpha. Correct or not?
Correct.
If you find the angle, you will be able to find this angle as well. Then the triangle will be complete, right? All the things we can find it. So we can find for the perpendicular distance d here. So perpendicular distance d, it will be if we find 3 meters and okay, I assume the name of this is C. The length of that part is C. Okay? So C there will be 0.65 divided by 2 square plus 3 square root of that. Correct, right? That will be the length of C. Correct or not?
Correct, sir.
Yes.
So after we find C and we find alpha, then how can we find the angle? Okay, C alpha and that one. Okay, then D per C, it will be the same as what is that? D per C is tan cos, right? This one cos 90 degrees minus 60 degrees minus alpha. Okay, we will be able to find D from that after we find C and tangent alpha. How can we get this 90 degrees minus 60 degrees minus 6 alpha? Because this angle is 60 degrees minus alpha, right? That one?
Yes,
Correct or
sir.
not? Okay, and this angle, it will be 90 degrees minus that, right?
Exactly, sir.
Yeah, so cos alpha here cos, for example, beta here, cos beta there, it will be D divided by C, right? Cos beta, it will be D divided by C, where beta is equal to 90 degrees minus 60 degrees minus alpha. So after we find C and alpha, we will be able to find D. You get it, guys? The calculation is a little bit complicated, but actually it's not that complicated. This is just a geometry, yes. Matthew, you understand, Matthew?
I think so, sir.
Okay, good. So after we find D, how can we calculate it? If we already find D, the perpendicular distance D,
F times D.
F times D, it will be what?
Momentum. Moment.
The moment. Okay?
Yeah.
F times D will be the moment. And beside that, what else that we have? Equivalent force couple system. Right? So remember, we have this cantilever. At the beginning, the force is like this, AF. Then we have to move this force to this particular point, right? Replace this with another force, F, where F is 8 kilonewton plus moment, right? So your final will be like that, where the F here is, the value of F here will be 8 kilonewton, and the moment here will be 8 kilonewton multiplied by D. So that's the first couple system that you're supposed to have. Okay? Azhar, do you understand? Who else here? I think,
Yes, sir.
who else here?
Sir,
Mhm.
I want to ask,
Hmm?
if the force miring ke atas, Pak, put in the corner at the top,
Gimana maksudnya? Gayanya?
jadi gini Pak, ini kan ke bawah ya Pak.
Mhm.
So kalau misalnya force-nya kita pindah ke pojok kanan atas dari kotak itu, dari cantilever itu.
Pojok kanan atas, entar.
Nah, iya,
Pojok,
tadi
pojok
itu.
kanan atas maksudnya sini?
Iya, habis itu ditarik ke atas.
Habis
Miring
ditarik
gitu.
ke atas.
Ditarik ke atas miring gitu. Enggak, saya
Oh,
masih
maksudnya ini maksudnya kamu menanyakan kalau ada soal baru,
iya.
tapi gayanya
Arahkan saya masih agak bingung.
arahnya gini gitu ya. Gitu ya. Nah,
berarti
kalau
nanti
seperti itu momennya akan hasilnya ya, kalau misalkan kasus seperti ini berarti soal baru ya. Ini jangan digambar di sini. Ini kalau ada soal baru. Seperti itu kan?
Iya.
Nah, kalau seperti ini, ya kita coba lihat perpendicular distance di mana. Gayanya tetap dipindah ke titik yang sama kan?
Iya.
Ini adalah line of action dua-duanya. Oke. Ini adalah D-nya. Oke. Nah, kalau dilihat seperti ini kan sekarang momennya jadi counterclockwise. Betul nggak?
Iya.
Jadi nanti hasil perpindahannya akan seperti ini. Caranya masih sama.
Oh, dan momennya juga kalau counterclockwise tidak, Pak.
Counterclockwise dalam hal ini.
Oh.
Besarnya berapa ya? 8 kilonewton kali D. Tapi D-nya sekarang ini. D1 lah ya. Berarti momen sama dengan 8 kali 8 kilonewton kali D1.
Oke, Pak.
Seperti itu. Tergantung arahnya. Oke? Saya coba cek ke yang lain. Okay, let me check to the other. Sunita. Do you understand, Sunita?
Yes, sir.
Aisha?
Yes.
Okay, good. S3. Hello, S3? Do you understand, S3?
I think so.
Oh, seems like you have problem with your connection. Do you understand?
Pak.
Yep.
To be honest, I still don't understand when it start to connect to the couple.
Who's this?
Rizky.
Okay, yeah, Rizky. This one?
I
Can you
still don't
repeat the
understand.
question?
I still don't understand when you start to connect it to the couple moment.
What do you mean by couple moment?
I mean, you said after we found the D, we can find the moment and the couple, right?
Yeah, couple and moment is actually the same in this case. So basically, right? Basically, when we couple is actually like this. Right? When you have two forces, exactly same magnitude but different direction, and parallel to each other, we call it as couple. Right? Yeah.
Yes.
I still cannot control this well. Hey, ayo. Okay, if we have two forces, the same direction, the same magnitude, opposite direction to each other, and parallel to each other as well, this one is couple. And couple, we can represent a couple here as this, like this as well. So this one and that one, this one and this one is actually the same. Both are the
Okay.
same. So actually, I can represent it like this as a couple, or I can represent it like
Okay.
this as a moment.
Okay. Okay.
Because couple always produce moment. So
Yes.
first couple moment, first couple system here is just the same as first moment system actually. Because we always know, we normally represent it as like this. This is what we call as first couple system or first moment system. Okay, Rizky?
Okay, Pak.
So whenever we move one force like this one to another location, what we will get is exactly the same amount of force, but we have additional couple. And you have to remember to delete this. Because if you don't delete that, the effect will be double. We cannot consider the force twice, right?
Yes.
So at the end, after we move it, it will be like this. After we move it, it will be like this. Okay. Any other question?
But I still don't understand. Like
So based on your explanation, when we move a force, its couple will just be there, like naturally.
Oh yes, that's correct. If we move a force from one point to each other to another point, which is not in the same line of action, you will produce a couple. We will produce a moment. Moment or couple is just the same. Okay.
So even in the original like exertion of force, it already has a couple from the start.
No, not yet. No. Don't make that kind of assumption. If it's in the original location, okay. For example, just now the problem is like this: F, right? Yes, of course. In this case, F there is no couple there because you don't move it to somewhere else, right? If
yes.
couple will be there, if you move it to another location, if you move a force to another location, which is not in the same line of action. You get it, Asya?
Oh, I see.
If you move it here to this particular point, the line of action is different, right?
Yes.
So like it or not, there will be a moment there. So after you delete this, there will be a force here. The same amount of force, F, but plus moment or couple.
Also, it's in reference to which one is the original position.
Yes, the moment will be the magnitude of the force multiplied by the perpendicular distance d in reference to the original position. This is
Oh,
d.
I see.
You get it?
Oh,
So
I get
couple
it.
is not always there, or moment is not always there from the beginning. But when you move force from one particular point to another point, which is not in the same line of action, then the couple will be there. The moment will be there. You get it, Asya?
Oh, I get it now, sir.
Okay, this is another example. Okay. Any other students here still have a question? Meryl, do you have any question, Meryl?
No, sir.
Okay, good.
I just understand.
Okay. Anyone? Shabina, do you understand, Shabina?
Yes, sir, but I think after this class, I will try to watch the video again.
Okay, good. Try to review. Okay. Seems like there is part that you still don't understand, right? Which part is that? Can you tell me?
I don't say I'm not understand, but
You need to review.
Yeah, I need to
Okay.
review.
Yeah, it's good. It's good for you if you can review. And because tomorrow is a holiday, right? And tomorrow I don't have class, so I will try my best to upload the video by today. Okay. Then
Sir, just want to
yeah,
ask,
yeah. Who's this? Meryl.
Meryl, sir.
Mhm.
Sir, if we ask you outside class time, would it be okay?
It's okay.
Okay,
It's okay.
sir.
But if you ask me via, oh yeah, the first thing that you can do, right? Because that's the job of my assistants to answer question from students as well. Try to ask the question via MST. Later, Nando or Rifki will help you to answer those questions first. But if you still not satisfied with their answer, then you can contact me. Okay.
Okay, sir.
Nando is maybe probably one of the best students that we have. So his GPA is probably is the highest in 2017 batch mechanical engineering. I believe it's more than 3.9. So I believe he's more capable. He's more than capable to help you guys as well. But for sure, sometimes assistant is still assistant. Sometimes their answer will not satisfy students. So you can ask me about it as well. Okay, madam? Yep. Who else here? Yep. Who's this? Rizky. Okay.
I want to ask, so what's the difference between conventional and
conventional and
couple? Like in the first meet we thought that to find a moment in a new point, just find its perpendicular distance and times it with the force. So what's the difference between that way and couple?
Okay, yeah. There is one big difference. When we have like this, it's actually a very good question, KFP. If we have force and we want to find the effect of the moment, the effect of that force F, for example, to this particular point A, okay? The effect actually they will if you have a force, right? They will always do effect of that particular force to another point, okay? Unless the point is in the same line of action, okay? If the point is at the same line of action, for example, this is point B, okay? The effect of force F at point B, sorry, why there is a, I put it like this, okay? The results, the effect of force F at point B, it will be just force only. Why force only? Because point B is in the same line of action. So the effect of force F to point B, it will just force. It will not cause any moment to point B. You get it? Because there is no perpendicular distance there. Do you get it or not?
Yes, yes.
Yeah. But if the question is, what is the effect of force F at point A? Okay, there will be two results there. There will be two effects. The first is the force itself will have the same effect at point A. But beside that, there will be a moment as well. Because there is a perpendicular distance between point A and force F. This one. Do you get it?
Yes, Pak.
Nah, that's one thing. Okay? Now, if we are talking about a couple, okay, it's different case. Okay? If we are talking about couple is always like this: F, and there is a perpendicular distance between both. Okay, and the force is parallel to each other, like this. Okay, this couple will not give any force effect to any point. So, for example, the total of this force system to point A, point B, point C, for example. Okay, so at point A, B, or C, okay, this couple will not give any force effect. Why? Because the force effect there is canceling out each other. The force effect from this force, the force effect from this force will be canceling out each other. Correct or not, Rizky?
Yes, yes, Pak.
But there will be a moment effect.
I see, I see.
So that's different between moment and couple. But you can actually represent couple as a moment as well, like this. So you don't have to represent couple as two forces like that, because it's simple to just put it like this.
Yes.
Do you get it?
Okay. Okay,
So,
I get it.
so that's the special thing about couple. It will not give any effect, force effect to any point of the body. Okay, but it will only give a moment effect. If it's just one force, okay, it will give in some point, it will give force and moment effect. In some point, which is in the same line of action, it will give only force effect. Okay, Rizky? Yeah. That's the difference between moment due to one force and couple, like that. It's supposed to be explaining everything, right? Rizky?
Yes, Pak. Thank you very much.
Okay, then. Now, actually, we already discussed about this. It's a force moment couple system. Sorry. Now we are talking about resultant. Okay, we are talking about resultant. So just now, actually, we learned about how to move one force to another point. Okay, and the things that I need to tell you guys is now is about resultant. How can we add one force with another forces? Okay, at certain point, for example. Okay, because why resultant is important? Because actually, sometimes we have to deal with more than one force in one system, more than one moment in one system. And luckily for us, okay, you can see here, force moment coupled system can be simplified to one resultant force as obtained location. So we can simplify it. But we have to add those together one by one in order to simplify. Don't worry about that. I will explain a little bit after this. Okay. Then this calculation, right? This calculation is very important. That's why never skip this one. Try to understand this basic because this basic is very important for this particular class, statics class, for the next semester's class, mechanics of materials, and for dynamics analysis as well. Okay, kinematics and dynamics as well. It will be very important. Okay. I think I will just go to the next one. Okay. Please don't look at the figure B, C, and D. Try to concentrate on figure A only. This is the first thing that you have to concentrate on. Try to ignore the rest. Okay. The things that we have to do right now is I want to sum, I want to add force F1, F2, and F3 together. I want to sum all of those together. But the first thing that I want to do is to sum it up at point O. I want to sum it up at point O. Okay, I want to sum it up at point O. I want to add F1, F2, F3, and The summation, I want to do it at point O. Okay. How should we do this? William Chwanda.
Yes, sir.
How should we do this?
We can connect together, sir.
That one is just a normal summation. Yes, you can do it. That's the first way to do it. But I want to sum it up at point O, William. Can I'm asking you, okay, William? Can I
Yes, sir.
move all the forces to point O? One by one. Can I do it? Oh, no, William. So
Yeah.
F1, I move it to point O. As a result, I will get a force and a moment or couple. Okay. F2, I move it to point O. As a result, I will get a force F2 at point O and a couple. And F3, I move it to point O. As a result, I will get a F3 at point O and a couple as well. Can I do it, William?
Yes, sir.
Then at point O, because everything is already moved to point O, then I can sum everything there. Okay, that's the easiest thing to do actually. So the first thing that we're supposed to do is to move F1 to point O. By moving F1 to point O, what we will get is, let's take a look at the figure B. Okay, is F1 plus moment. F1 plus moment. The moment is F1 multiplied by D1, where D1 here is the perpendicular distance from F1 to point O. Then F2, move it to point O as well. This is what we will get. Plus moment, where the moment is F2 multiplied by D2. D2 here is the perpendicular distance from F2 to O. Then the last one, F3 move F3 to point O. And we will get as well there is M3. F3 multiplied by T3. T3 here is the perpendicular distance. Okay. By doing so, we move everything to point O. By doing so, we can, everything is happening, all the forces are happening at one point. So, and all the moment will be there as well. So we can sum all the moment and we can sum all the forces using vector summation. Okay, this is the results of the summation at point O. You get it, William?
Yes, sir.
Yeah.
So, sir, the summation of the force has nothing to do with the summation of the moment.
Yep. In this case, yes, because the moment you can sum it together. So moment 1 plus moment 2 plus moment 3 directly. But remember about the direction, okay? Moment 1 here is clockwise, moment 3 is clockwise, moment 2 is counterclockwise. So in this case, M1 plus M3 minus M2, and the result is clockwise. You get it?
Oh, okay, sir, I get it.
I still don't get it how to determine the
force.
rotation. The rotation.
It's kind of still vague as well.
Oh, the rotation. Oh, why the rotation is like that? You mean?
Yes.
Okay. Let's see F1. F1. This is the line of action. F1. Okay. Let's take a look at the first picture. Okay, picture A. F1, and we have D1 there. Right? D1 is the perpendicular distance from F1, line of action of F1, to point O, right?
Yes.
Okay. Then you can see if the center of rotation is at point O. Remember, moment is always, in order to determine the direction of the moment, always take a look at the original picture. Right?
Okay.
The original picture is the picture number 1. So
Okay.
imagine that O is the center of rotation.
Okay.
If O is a center of rotation and F1 is there, like that, at the original position, what will be happening at point O? What kind of rotation will be happening at point O?
Going to up and right.
Up and right. So clockwise, right?
Yes.
The same as this one, right?
Okay.
That one
I
clockwise.
see. Okay.
Yeah.
I see. I see. I see.
Now F2.
Okay.
F2 is like this, right?
Yes.
P1,
Yes.
P1 is there, center of rotation is
Up and left.
O,
Yeah.
up and left. So counterclockwise, right?
Yes.
That's why it's like this, is counterclockwise.
Okay. Okay.
So the
F3
left
the
and
same.
right is relative to the line of action, not to the point.
No, line of action relative to the point. You can see it. This is the line of action. Okay, the direction is going there. Okay, and center of rotation is at the point O.
Also, like the up and left comes from the O being on the left of the line of action.
Oh yes, of course.
Oh, I see. I see.
Because center of rotation, always think O as a center of rotation. Then F, direction of the F. What kind of rotation will be happening because of that? So it's always the
Anti-clockwise
relation
is-
between the line of action, direction of the force, and the center of rotation, O.
Sir,
You get it?
I have another
I
question.
get it, sir.
Yep. Who's this?
Zeke.
Six.
So you see in the figure C, right?
Mhm.
The rotation is clockwise. Why?
Oh, actually, I'm not so sure about that because everything it depends on the value of F1, F2, F3, D1, D2, D3. So here the assumption is the value of F1 D1 plus F3 D3 is bigger than the value of F2 D2.
Yeah. So that means that M3 and M1 is bigger than M2, right?
In this case, the assumption is like that.
Yeah.
If M2 is bigger, then the direction is supposed to be the opposite. That's all.
So it,
Okay.
it will be counterclockwise if M2
Yes,
bigger.
correct. Yeah. If if M2 is bigger than M1 plus M3, then the direction will be counterclockwise.
Okay, I see.
Everything depends on the value.
So
This is just an example. Yes.
so all of this concept just to determine where the rotation is.
Correct.
Amazing, sir.
Amazing. What's so amazing? What?
Okay.
Okay. Now, how about the resultant of the force? How can we get that kind of direction from F1, F2, then and F3?
Referring to the first.
Yeah, this one. This one is the resultant of the force, right? It's supposed to be coming from F1,
Yes.
F2, and F3, right? So actually, R here, R is R is actually the same as F1 plus F2 plus F3. Yeah, this one. R here is the same as F1, F2, and F3 plus F1 plus F2 plus F3. But remember, this one is factor. So the summation is supposed to be summation, factor summation. For example, is F1. If F1 is A I plus B J like that. F2 is C I plus DJ, for example. F3 is EI plus FJ. Then the resultant is supposed to be A plus C plus E I plus B plus
B plus
E
D plus
F
J.
J, like that. Okay, you get it? Yeah, it's just a factor summation. Okay, remember that the summation is supposed to be factor summation. What's wrong with this? Okay. Do you get it, guys? Supposed to be okay, right?
Yes, sir. Yes.
Yeah. And the last thing is I want to represent those force and a couple. This one, figure C, okay? Figure C is a force and couple system. But I want to just represent that force and couple system to just one force. Can we do it? Yes, we can. Just now remember, we can represent one force into a force couple system, right? From the previous one by moving the force from one point to another point. By doing the opposite, we can get the same, by doing the opposite, we can get the opposite effect. So force couple system, okay, we can trace back by, we can trace back the force, okay, move the force back to the original position, so it become just one point. Sorry, just become one force instead of force couple. So actually figure C and figure D actually is actually exactly the same. Exactly the same effect, has exactly the same effect. The same as figure A and figure A and figure B. But for figure D here, it's just one force. It's just one force. How to do it? Yeah, how to do it? We do it the opposite of what we do before. Okay. Here, okay, remember when we do it here, okay, we replace one force with one force and couple. So one force, we replace it with force and couple system. Okay, now we can do it the opposite way. So we can replace force couple system with one force only, but the effect is supposed to be same. You get it? You get it, guys? Hello, Sik. You get it, Sik?
Yes, sir. Yes.
Okay, we can
this
just
comes
do the
from like
opposite.
from the couple to a single force, yeah.
Yes, previously from single force to a couple. Sorry, from single force to force and couple. Now from force and couple to single force. So we do the opposite of what we do before.
Also in the previous one we were like kita ngebongkar dari resultan ke couple, kalau sekarang jadi couple ke resultan.
Betul. Kalau yang sebelumnya itu satu gaya, kita pindahkan ke titik lainnya. Oke, dari satu gaya kita pindahkan ke titik lainnya, hasilnya adalah gaya dan couple.
Oh, ini dari berbagai macam titik.
Kalau yang sekarang kita punya gaya dan couple, kita pindahkan. Oke, kita pokoknya tadi caranya kebalik ya. Caranya kebalik. Jadi kayak jadi gini. Okay, so if we do it the opposite way, okay, this one actually, if we process it the same as what we do before, by moving the force to point O, what we will get, it will be exactly the same, force and couple like this. So if the process is opposite, okay, so we have R here, just one force only. Then this is the first one. The second one is I want to move R to point O. Okay. Then I move R to point O. At the same time, I will get a couple. R multiplied by D, where D is the perpendicular distance. Okay. But the process is slightly the opposite of what we do before. This is what we do before, from one force to force couple. Now, in this case is what we have is like this. Force couple. Okay, what we have is like this force couple, and now I want to represent it to just one force. How can we do that? So actually, we can just do exactly the opposite of what we do before. Okay, we have a moment like this. Now, because it's the opposite, right? This is our first process, and this is our results. Okay, we have force and couple. Okay, the couple is clockwise. If the couple is clockwise, and the force is going to the top right, okay, then actually I can just represent it with just one force. But the location of the force supposedly create a moment, clockwise moment, right? Creating a clockwise moment. Now the logic is becoming like this. Okay, we have a force couple. I want to just represent as one force. Then that one force supposed to create the same effect as the force couple. The force couple here having a force going to the top right and moment. Okay, the moment is clockwise. So, like it or not, when we have only one force, the force supposed to create a moment, clockwise moment at point O here. Correct, right? The force is supposed to create a moment, a clockwise moment at point O. And the value of the moment is supposed to be the same as this one. That's why, because the magnitude is the same, this one is R and this one is R, the one that we can control right now is the distance t, perpendicular distance t. So the perpendicular distance t is supposedly the same as moment, the moment here, divided by our resultant force, R. Right? Do you get it, guys? So now we can represent first couple into just one force with certain distance from the original position. The original position is O here. Now the location is at distance d, perpendicular distance d from O, where perpendicular distance d follow this moment divided by R. Do you get it, guys? See? Risky?
Yes, Pak. I get it.
I think in order for you guys to understand better, there will be several homework. There will be several things that you can find. This is one of those. This will become one of your homework, and I will give you like maybe three or four problem for your homework, and you have to submit it by next Thursday. Okay, next Thursday before class. So supposedly the deadline is 10 in the morning next Thursday. Okay, and this one will be one of the problem that you're supposed to do. Do you get it, guys? It's already close to 12 in the afternoon. So like it or not, I have to end the class today.
So it's only this question for the homework?
No. I'm telling you, there will be 3 to 4 problems. So just wait for the file. I will send the file as soon as possible to the MS team. And
Okay,
this one will be one of those.
Okay.
Okay.
Thank you very much, Pak.
Okay. I think that's all for today. Okay. If you have any question, please. I think the things that you can do right now is try to do the homework. Okay. Next week, at the beginning of the class, if you have a problem with the homework, and if you have any questions about the topics that we discussed today, you can ask me then at the beginning of the class next Thursday. Okay.
Excuse me, Pak.
Irfan, yes.
If we want to have a permission to be absent, should I contact you through MS Teams or other?
Absent? What's wrong?
Yes. I think next week on Friday I'll have I'll have a acara that I cannot skip next week Friday.
Okay. In that case,
Yes.
because you want to make it official or not? If you want to make it official, you have to make a letter, formal letter from you, and supposed to be signed by your parents as well, and send it to me. In that case, then I will still consider you as absent, but